Hey, all right, so I'm still at reInvent, so sorry about the noise again. I seem to have a knack for finding construction sites, or they're finding me. Either way. So sorry about the noise. Should be better tomorrow when I'm home again. Okay, another day of advent of code. So let's take a look at the um, let's look at today's problem. Excellent. Okay. So, day two, rock, paper, and scissors. The elves begin to set up camp on the beach. To decide whose tent gets the closest to the snack storage, a giant rock, paper, scissors tournament is already in progress. Rock, paper, scissors is a game between two players. Each game contains many rounds. In each round, the players each simultaneously choose one of rock, paper, or scissors using a handshake. Then a winner for that round is selected. Rock defeats scissors. You know how it works. If both players choose the same shape, the round instead ends in a draw. Appreciative of your help yesterday, one elf gives you an encrypted strategy guide, which is your puzzle input, that they say that they say that that they say will be sure to help you win. The first column is what your opponent is going to play: A for rock, B for paper, C for scissors. The second column, and suddenly the elf is called away to help with someone else's tent. The second column, your reason, must be what you should play in response: X for rock, Y for paper, and Z for scissors. Winning every time would be suspicious, so the responses must have been carefully chosen. The winner of the whole tournament is the player with the highest score. Your total score is the sum of your scores for each round. The score for a single round is the score for the shape you selected: 1 for rock, 2 for paper, and 3 for scissors, plus the score for the outcome of the round: 0 if you lost, 3 if the round was a draw, and 6 if you won. Since you can't be sure if the elf is trying to help you or trick you, you should calculate the score you would get if you were to follow the strategy guide. For example, suppose you were given the following strategy guide: A, Y, B, X, Z, C, Z. Saying Z is really hard, by the way. Okay. This strategy guide predicts and recommends the following. In the first round, your opponent will choose rock. You see the A here. And you should choose paper, which is Y. This ends in a win for you with a score of 8. 8 because you chose paper, and 6 because you won. In the second round, your opponent will choose paper, and you will choose rock. And this ends in a loss for you with a score of 1 plus 0. So 1 from choosing rock, and 0 because you lost. The third round is a draw, with both players choosing scissors, giving you a score of 3 plus 3. 3 because scissors, and C, and another 3 because it was a draw. So in this example, if you were to follow the strategy guide, you would get a total score of 15. 8 plus 1 plus 6. What would your total score be if everything goes exactly according to your strategy guide? Your puzzle answer. Oh, that's spoilers. Okay, so just like yesterday, what I did first was I shoved the data into a sample file right here. I added to my test file that when I run part A against my sample input, I'm supposed to get 15. And then I went to work. Okay, so today is not very elegant at all, but I feel like it's descriptive. And I needed that last night. I was at a conference, maybe a little cognitively challenged, so I had to spell out a lot of stuff so I could follow along. Um, I can I saved some of the uh, earlier versions in Git, so you can take a look at those, or maybe we can take a look at them together. But they were very verbose and yeah, not very straightforward. So this is what I boiled it down to today when I rewrote it a little bit. Again, that's something that's really easy when you have the tests, because you know that what you have is working, and then you can just keep refactoring. So changing the structure, or yeah, just changing the way that you try to get to the same results. And your tests tell you that if you broke something along the way. So this is what we have right now. Again, two parts to it. There's loading the data from the file, and then there's the second part of taking the data that you got and get to the result that you were asked for. So let's take a look at the get data function. It's down here. Very straightforward. Create an empty array for the return value. Open the file, and then for each line, we strip any white space. Then I took a look and made sure that there's one space between them. That's great. So we could just call L.split. So we split the line on spaces, and we put the one value into A and the other value into B. And then we add those to the return value as a tuple. And ultimately return that return value. And then, it's been so long since I did any serious Python work. So this whole specifying types and whatever is very new to me. So this was a first, adding these things. It's been a couple of years, which is why I'm doing Python, by the way, for this, because I want to make sure that I keep it fresh. Same with Go. Anyway, so we get the data out, and then just to make it easier to follow, I create a mapping called their move map, which basically takes what we see in the file, the A, the B, the C, and turn that into a move that we can understand, so that it's when you're reading through it, it's easier to kind of say, oh right, yeah, rock beats scissors. It's easier to imagine than A beats Z, right? So this helps us map the input data to something in our problem domain, right? So the input data is encrypted, as the elf said, I think. And now it's turned into something that we can use as humans. Apparently I do that twice. That's a little wasteful. All right. So again, this is a pretty common pattern apparently in these admin of code things. So you have a iterate thing, and you count scores and you whatever. So again, we initialize the score to 0. We go through the data, and we know that each line represents their move and my move. And this line right here just gives me two variables, them and me, that represents the letters. So in the first case, it's going to be A and Y. Whoops. And then we use their move map to turn that into the rock, whatever it was. It turns into like the string, either rock, one of the strings, rock, paper, or scissors. And the same for this, for my move. And then we have a round score function, which first of all makes sure that we're actually passing in a valid move. Otherwise, debugging that would be frustrating. If we have the same move, it's a draw. If they have rock and we have paper, it's a 6 because we win, or 0. Maybe I should explain this one. So if you have a bunch of true statements, so if you do let's just say true and true and true, that's boring as hell, but the outcome, so if we did something like this, X would, after this, have the value of true. So just like in pretty much any programming language, when you join statements together like this, in C-like languages, it would be something like this: true, 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 right? So the return value of that is the final value that we have over here. So in this case, it would be true. Um, and evaluation stops as soon as it knows what the outcome is going to be, right? So if this had been false, uh, and we have another one after here. So the outcome of this one would be false because we have an and statement here, and as soon as we get there and we have a false value here, the interpreter knows that there's no. It doesn't matter what this value is going to be because it's gonna be false because we have a false value in here and we are doing a logical and on it. So the return value of this one is going to be false, I think. This is not usually how it looks. Usually I have like an expression here that is what matters, and here we have this. We could put the parentheses in there. Maybe that makes it easier. So this statement right here is obviously true if my move is paper, and if my move is paper and their move is rock, then I want the 6, and that's what happens here. So this is true, and then there's an and then tells the interpreter that okay, I started out with a true statement, and then there's an and, so I need to evaluate the next one to find out what should ultimately be returned from this, compound expression, right? So in this case, that's 6. But in case this is false, we have an or, which is so we use this to get a value that corresponds to this being false, right? I hope that's relatively clear. So it's yeah. Why didn't I think of this? So in case you are familiar with C or many other languages in the C family, this is going to be equivalent to that. Let me see. Right? Does that make sense? So it's basically it's the same thing, just expressed in a Pythonic way. There we go. Yeah, so that's the round score. So we go through. If it's a draw, it's 3. If they have rock and we have paper, then we win and get a 6. If we don't have paper, then we must have scissors because we would have caught it here if we had both been rock, and here if I had been paper and they had been rock. So this is the only choice left. Same thing here, paper they have, and scissors 6 and 0, blah blah. And finally, if they have scissors and we have rock, we win, and they lose if they have. No, if we have. So can you imagine if I was trying to do this in my head just with X, Y, and Z and A, B, and C? I can't even do it when I'm calling it rock and scissors. Anyway, I know this is true because I had an earlier test for the first version of this function, but it went away along the way. But honestly, that's something I should have done. I should have added that. Let's do that now. Okay, so this one's called round score. Round score. Round score. We pass in, suppose we have, that's their move, rock, and we have scissors. So they win because rock beats scissors, and We have scissors, rock, paper. That's 3 points, I think. Let's see. Hands, scissors is 3. Okay, so this is supposed to give us 3. Let's, no, that's supposed to rock. That's supposed to give us 3. That's supposed to give us 6. 3 because it's a draw, and 3. No, wait, rock. Wait. No, rock is 1 point. All right, let's do scissors. This is another. So let's just run it straight over. It fails. Wow, cool. Assertion 4 does not equal 1. Which one is that again? Line. Oh man, it's hard. Why can't I find this out? What can't I spot it? There. Line 8. Okay. No, go away. Go away. Line 8. This one is wrong? Yeah, rock and rock. Yeah, that's supposed to be 4. I thought it said 4 just a second ago. Run it. Okay. So sometimes I do this. I don't know if this is super obvious and everyone does it, but I do it a lot. Like, if I'm fairly confident that the code I've written is right, sometimes it's not straightforward. In this case, we can reason about it. We can talk about what the score is going to be. Every once in a while, it's not completely straightforward. So I'll write the test case, and using the code that I already have, I'm going to say, okay, it says 6 does not equals 1. Okay, so it returns 6, but because I just copied this. I didn't know what this value was going to be because I didn't work it out. It's at 6, right? Jeez. Yeah, 6. And then I can think, okay, so scissors and scissors is a tie, or draw. That's 3 points. And scissors is the third one. Rock, paper, scissors. That's another 3 points. That's 6 points. Yep, that checks out. So nothing wrong with that, right? Just put them in. Like the things that you want to validate works. This is a reasonable selection. I could put in all of them. That's what I did with the first one, actually. But you can just put these in just as a sample. And if there's one of the values you're not completely sure of, just put it in and see what it errors out with. And it says, well, it's supposed to be 6. And you can be like, yep, that tracks. Put it into the test. And then you know that, from now on, it's gonna work out. You can always catch it later if you realize that you were wrong about what the output was supposed to be. But boom, here we are. So let's go back here. We have the round score. So we have the outcome score. Then there's the hand score, which we talked about. And then we returned the total. Sweet. And we add it to the score, and we don't need to continue anymore either. That's from olden days. And that's it. Part A, boom. Yeah. And then as soon as that worked, I could just run the file and have this bit down here that runs it against the full input. Cool. All right, so I did that. We got the result and filled it in. And my puzzle answer was 11,906. Cool beans. All right, part 2. I just remembered that you don't see my screen. So I need to change this. All right, so it says here my puzzle answer was 11,906. Boom. All right, part 2. The elf finished helping with the tent and sneaks back over to you. All right, anyway, the second column says how the round needs to end. X means you need to lose, Y means you need to end the round in a draw, and Z means you need to win. Good luck. Okay, not exactly what we're expecting. That's fine. So total score is calculated the exact same way. But now I need to figure out what hand I need to use in order to get the outcome that we want. So we go through the motions again here. It's basically telling you how to write your unit test, right? So it says here in the first round, your opponent will choose rock, and you will need and in a draw, so you also choose rock, and this gives you a score of 1 plus 3 equals 4. So yeah, this really tells you that um, this gives me the values for my test case, right? So in the first round, opponent will choose A, and I choose, they choose rock, I choose rock, and that's supposed to give 4. Right, we have it there, actually. What's the other one we have? In the second round, your opponent will choose paper, and you choose rock. Paper and rock, and that's supposed to give 1. Yeah, so in the second round, paper, rock, and 1. Okay. Paper, rock, toast. Thank you. And finally, let's see, third round, your opponent's scissors, and we do rock, and that's supposed to get 7. Scissors, rock, 7. Yep. Run the test, please. And we're still happy. We knew that because I finished this, right? So I knew. But still, that's sweet. Okay, so now that you're correctly decrypting the ultra top secret strategy guide, you could get a total score of 12. Following the alt instruction for the second column, what will your total score be if everything goes exactly according to your strategy guide? And to do that, this is not this is not particularly elegant. So once again, I have their move map to figure out what their move is, and there's probably better ways to do this, but this is what came up with. So I have my move map, which is a map that the first part is the opponent's move, and yeah, for this one I actually stuck with X, Y, and Z instead of win, lose, draw, because that just doesn't help anyone. So if their move is rock, and I'm sorry, you guys are still looking at Firefox. Cool. Still getting used to this. Sorry. Okay, so we're looking at part B here. So there's their move map, which we use to map the input from the file into an understandable move, right? And then I have this. Like I said, it was pretty inelegant. There's my move map, which takes their move as the first key. It's a multi-dimensional array, right? So with the first dimension being their move, and the next dimension being the desired outcome. So X means I need to lose. Yeah. So if they play rock and I need to lose, I need to play scissors. If they play rock and I need to draw, I need to play rock, etc. Right? So once again, I call get data, start out with score of 0, and then here I say that the first value is their move and the second value is the outcome. So, oh, again, I have some dead code here. Sorry about that. Okay, so we found out what their exact move is by looking up the input in this map right here. I should be able to fit on the screen. Yeah, here we go. So it's all on the screen. So that's their move. And then I need to find my move. Like so. And then I need to move it down here. My move. Okay, so their move, we get that directly from the file and look it up in this map up here. My move, we get by taking their move first, with the my move map right here, taking their move. In the first case, that was they pick rock, and I want it to be a draw. So I pick rock as well. Then we count the score, and once again, I've left in that continue from some earlier work. There we go, and hopefully that should make the test pass, and it does. And that's it. I know that yesterday I said that I was doing it both in Python and Go. Apparently, time does not care, so I didn't get around to doing that. Maybe I will. I think I'll probably do Python every day, and then yeah, whatever I feel in the mood for it. Maybe it's not going to be Go every time. I really want to get. I want JavaScript to feel more natural, so I might do that. Uh, yeah, I don't know. Ideas? Anyone? Um, anyway, that's what I did with day 2 of Advent of Code. I hope this was I don't know, useful. I guess. If you have any questions or comments, leave a comment. If you have any comments, leave a comment. So, otherwise, smash that like button or subscribe button and like and hit subscribe. You know what I mean. Yep, that's it. All right, thanks. Bye.